A phone chip that panicked an entire industry, a secret software update that cost Apple $500 million, a chip that quietly became the foundation of Apple's laptop line, and a phone that eventually outperformed the laptop it built. This is every iPhone processor, and the stories Apple hoped you wouldn't notice. Apple A4. In 2010, Apple had a dependency problem. Every chip inside every iPhone was built by someone else. Apple was a software company running on other people's silicon. That had to change. They paid $278 million for a company called PA Semi, then acquired Intrinsity, combined the teams, built the A4. Single core, Samsung 45 nanometer, clocked higher than anyone else had managed on the same architecture. Here's what most people miss. The A4 was the first processor ever built specifically around a Retina display. Apple didn't upgrade the screen and then find a chip to run it. They designed the chip to make the screen possible. One other detail. The lead architect was Jim Keller, the same engineer who later designed AMD's Zen. Apple had him first. Apple A5. 2011. Apple doubled the GPU. The A5 delivered roughly 9 times the graphical performance of the A4. Games on the iPhone 4S ran with better textures and lighting than their Android counterparts. Mobile gaming permanently changed, but Apple also revealed something about how they operate. When Siri launched, Apple declared it an A5 exclusive feature. The A4, they said, lacked the computational power. Hackers proved that wrong within weeks. Siri ran on the A4. It had been locked to sell upgrades. Apple A6, September 2012. This is where Apple stopped borrowing and started building. The A6 introduced Swift, the first CPU Apple designed entirely from scratch. Not an ARM design with tweaks, a clean sheet, their own pipeline, their own execution units. Certain logic blocks were hand-drawn by engineers to maximize density, a technique most chip companies had replaced with automation years earlier. Qualcomm shipped quad-core Snapdragon S4 Pro chips that year. Apple shipped 2 cores and won every benchmark that mattered. Swift cores were wider, more instructions per clock cycle than Qualcomm's 4 standard cores combined. The lesson Apple learned with the A6 is the same one they've followed ever since. More cores is the wrong answer. Better cores is the right one. Apple A7, September 2013. And this is where the story gets uncomfortable for everyone else. The A7 was the world's first 64-bit mobile processor. 1 billion transistors, an architecture called Cyclone with execution width comparable to desktop CPU, and a secure enclave, a hardware vault for Touch ID data that even Apple's own code couldn't read. Watch for this. Qualcomm's CEO publicly called 64-bit mobile a marketing gimmick. That became one of the most embarrassing wrong predictions in tech history, because internal emails later showed the A7 sent ripples of disbelief through Qualcomm's offices. Nobody had seen it coming. Qualcomm scrapped their roadmap, abandoned their custom crate cores, rushed 64-bit using off-the-shelf ARM designs. That panic produced the Snapdragon 810, the chip that overheated so badly it nearly broke Qualcomm's reputation for 2 straight years. Apple's 64-bit announcement didn't just beat Android, it accidentally broke it. Apple A8, 2014. TSMC's 20-nanometer process, 2 billion transistors, a new GPU API called Metal, direct hardware access for developers, bypassing the abstraction layers that had been throttling mobile graphics for years. The A8's GPU benchmarked against the PlayStation 3's RSX chip in raw throughput. Apple called it console class. For the first time, they could back that claim. Here's the catch. Apple shipped the iPhone 6, their best-selling device ever, with 1 gigabyte of RAM. The Galaxy S5 had 2. The result was Safari constantly reloading tabs from scratch. Console-class graphics, constrained by a RAM decision that frustrated millions of users for years. There's a longer story in the Metal API, though. Direct hardware access sounds like a developer footnote. It wasn't. Metal became the graphics foundation Apple carried from iPhone to Mac. Every Apple Silicon chip that runs Final Cut Pro or Logic or console-quality games natively today traces back to the API Apple quietly shipped inside a phone in 2014. Apple A9, 2015. For the first time, Apple couldn't get enough chips from one factory. Demand for the iPhone 6s forced them to source the A9 simultaneously from Samsung, 14 nanometer, 96 square millimeters, and TSMC, 16 nanometer, 104.5 square millimeters. Same name. 2 completely different chips. Users figured it out. Ars Technica ran controlled tests. The TSMC version lasted roughly 22% longer under CPU load, around 2 hours. Apple said the real-world difference was 2 to 3%. This is the only time in Apple history that customers could look up a serial number to find out which foundry built their phone. Many did. Some returned them. Apple offered nothing. Most people missed the A9's most important feature entirely: NVMe, storage over PCIe, the interface used in MacBooks. Storage 70% faster than the eMMC standard Android was still using. The iPhone 6s felt faster than it had any right to because of a storage controller nobody talked about. Apple A10 Fusion. September 2016, new architecture, and the beginning of the biggest scandal in iPhone history. 2 Hurricane performance cores, 2 Zephyr efficiency cores consuming 20% of the power. TSMC exclusively. Samsung fully dropped. 3.3 billion transistors. Single-core performance comparable to the 12-inch MacBook of the same year. A phone chip matching a laptop. But here's what most people never found out. In January 2017, Apple quietly pushed iOS 10.2.1. Inside that update, code that capped the performance of aging iPhones. The A8, the A9, the A10 Fusion. Apple never announced it. Their reasoning: aging batteries couldn't sustain the peak current these chips demanded. Rather than let the phone shut down without warning, they smoothed the power draw, quietly, without telling anyone. A Reddit user named TechFire noticed his iPhone 6s ran faster after a battery replacement. Primate Labs confirmed it. December 18, 2017, using Geekbench data from thousands of devices. Apple admitted it December 20th. Apple settled for somewhere between $310 and $500 million, with individual payouts estimated between $65 and $92 per affected device, depending on the final claimant pool, distributed starting in 2024. France fined them 25 million euros. Italy, another 10 million euros. Battery health arrived in iOS 11.3. They offered $29 battery replacements through all of 2018. The technical decision was defensible. The secrecy cost them $500 million in 2 years of headlines. Apple A11 Bionic. September 2017. The neural engine arrived, and Apple's performance lead became genuinely embarrassing for the rest of the industry. The A11 introduced dedicated AI hardware, 2 neural engine cores running at 0.6 TOPS, built specifically to process the 30,000 infrared dots Face ID needed to read in milliseconds, first in any smartphone. All 6 CPU cores could now run simultaneously. The A10 forced a choice between performance and efficiency clusters. The A11 ran everything at once. Here's the number that tells the real story. Apple's A9, released 2 years earlier, was still outperforming the brand new Snapdragon 835 in single-threaded tasks. Android's best chip in 2017 couldn't match an iPhone processor from 2015, and the neural engine locked entirely to Apple's own apps. Every third-party developer on the App Store locked out. All that AI hardware sitting unused by every app you actually ran. Apple A12 Bionic. September 2018. The first 7-nanometer chip ever shipped in any commercial product, anywhere. Not just the first in a phone, the first. While Qualcomm was still on 10-nanometer, Apple was a full node ahead. 6.9 billion transistors. The neural engine jumped from 0.6 to 5.0 TOPS in a single generation. 9 times the performance at 1/10 the energy. Months before launch, benchmark leaks hit the internet. Multi-core scores over 11,000. Analysts called them fake, assumed they were mislabeled MacBook results. Some published articles questioning whether the data was fabricated. They were real iPhone scores. Single-core performance matched a 2017 iMac running a desktop Core i5, a phone. Benchmarking even with a desktop computer. And quietly, Apple placed a version of the A12, the A12Z, inside the Mac Developer Transition Kit they sent to developers to prepare for Apple Silicon, a phone chip previewing the Mac's entire future. Apple A13 Bionic, September 2019. Refinement. But the gap that was opening underneath is the real story. TSMC's enhanced N7P process, 8.5 billion transistors, machine learning accelerators built directly into the CPU cores, matrix math running inside the processor die itself, not just in a separate block. Deep fusion photography analyzed 24 million pixels across multiple exposures to produce detail no single shot could capture. Most people never absorbed this number. The Snapdragon 8 Gen 2, released in 2023, provided roughly equivalent single-core performance to the A13 Bionic from 2019, 4 years. Android's best chip in 2023, matching Apple's chip from the iPhone 11. And the reason the gap was that large? Apple had been running machine learning math inside the CPU fabric itself, since this chip, not just in a separate neural engine block. The A13's ML accelerators were doing matrix math at the core level before anyone else called it an NPU. They were building the architecture everyone else would spend years trying to catch. Apple A14 Bionic, September 2020, the first 5nm chip ever manufactured. 11.8 billion transistors, a 16-core neural engine. But the headline isn't what the A14 was, it's what it became. Tech Insights performed forensic die analysis on both the A14 and the M1 chip Apple unveiled 2 months later to replace Intel in the Mac. Their finding, the Firestorm and Ice Storm cores in the A14 are microarchitecturally identical to those in the M1. Same decode width, same execution units, same instruction set support. Apple wasn't just building a phone chip, they were building their laptop through the iPhone. The phone came first, the MacBook followed 2 months later, using the exact same cores, doubled in count, with Thunderbolt and PCIe added around them. In multi-core benchmarks that year, the A14 beat the Snapdragon 888 with 2 fewer performance cores. The efficiency advantage had become structural. Apple, A15 Bionic, September 2021. And Apple did something they'd never done before. They didn't compare this chip to the A14. Every Apple chip launch had shown a bar chart against the previous year. The A15 slide compared itself to the competition. The lead over Android was large enough to show. The lead over their own A14 was close enough to be awkward. Cinematic mode needed real-time depth mapping across every frame of video, more memory bandwidth than the A14's cache could sustain. So Apple doubled the system-level cache to 32 megabytes before cinematic mode even existed publicly. They built the hardware around the feature first. ProRes recording arrived on Pro models. iPhone as a cinematography tool, no longer a stretch. One more thing, Apple used the A15 again in 2022. The iPhone 14 shipped with it, 1 year after the 13 Pro, the same chip. 2 different price points, 1 year apart, quietly, without making it a headline. Apple A16 Bionic, September 2022. Apple called this a 4nm chip. Technically, it wasn't. TSMC's N4P is a refined 5nm family node. The actual 3nm transition came later. The 4nm label was marketing adjacent. What the A16 genuinely delivered: 16 billion transistors, a dedicated display engine, a separate low-power silicon block keeping the always-on display alive at 1 Hz while the rest of the chip slept, an ISP processing 4 trillion operations per photo for the 48-megapixel sensor. Single-core performance 40% ahead of the Snapdragon 8 Gen 1. Here's what Apple never mentioned. Hardware ray tracing was fully built into the A16's GPU silicon. Internal leaks confirmed it was pulled before launch. A power drain flaw made it unusable. Apple saved it. Launched it 1 year later as the A17 Pro's headline feature. The world first was real. The timing was engineered. Apple A17 Pro, September 2023. Bionic dropped. Pro arrived. The most powerful iPhone chip ever, and it ran too hot. First true 3nm chip in history, Apple reportedly purchased TSMC's entire first-year N3B capacity. No other company could access 3nm for a significant period after the iPhone 15 Pro launched. 19 billion transistors. Hardware ray tracing finally shipping. 4 times faster than software-based solutions. Neural engine at 35 TOPS, the threshold Apple later set as the minimum for Apple Intelligence. Resident Evil Village, Death Stranding, Assassin's Creed Mirage, running natively on a phone. And then it overheated. The iPhone 15 Pro hit 41.2 degrees Celsius during intensive use. Instagram, Uber, not even demanding apps, triggering thermal runaway. Teardown analysis found the titanium chassis Apple chose for that model conducted heat roughly 20 times worse than aluminum. The chip had no room to breathe. iOS 17.0.3 patched background process bugs on October 4th. It did not throttle the chip. Geekbench scores held identical or climbed slightly after the update. Apple never admitted the chassis was the problem. They remembered this. The fix came with the next generation, Apple A18, September 2024. The defining decision wasn't the chip, it was the memory. 8 gigabytes of RAM, standard, across every base iPhone for the first time. Not for speed, not for multitasking, to host the large language models Apple Intelligence required to run on-device. Apple's LLMs needed 8 gigabytes to load. So the A18 set that as the floor. Every iPhone it powered became capable of full on-device AI. including the new iPhone 16e, the first entry-level iPhone capable of running Apple Intelligence entirely locally. Qualcomm led multi-core that year, Apple led single-core. The pattern held for one more chip, Apple A18 Pro, September 2024, and for the first time in approximately a decade, Android One. Qualcomm had spent 12 years watching Apple run the same playbook: build your own cores, get off ARM's reference designs, make them wider and faster rather than adding more of them. With the Snapdragon 8 Elite, they finally ran it themselves. Custom Orion cores, fully in-house. Their first custom CPU architecture since 2012, mirroring the exact strategy Apple had been running since the A6. And for the first time, it worked. Geekbench 6 multi-core, Snapdragon 8 Elite, 9188, A18 Pro, 8744. Android had crossed Apple on multi-core. Here's the context. Android phones run 8 to 10 cores. Apple runs 6. Multi-core parity happened because Qualcomm added more cores, not because they matched Apple core for core. Single core, the number that governs UI speed, app launches, everyday responsiveness, Apple A19. September 2025. And after years of the neural engine sitting in its own isolated corner of the chip, Apple started tearing down the wall. TSMC's N3P, 10% smaller footprint than N3E, around 21 billion transistors. GPU performance up 33% over the A18, the largest single-generation GPU jump since the A11 Bionic. But the architecture shift underneath matters more than the number. Apple integrated neural accelerators directly into every GPU core. Since the A11, the neural engine was a separate island on the die, a dedicated AI block sitting apart from everything else. The A19 starts dissolving that boundary. Every GPU core now assists with matrix multiplication. The NPU and GPU are converging. Apple also built a dedicated low-power display block specifically for the iPhone Air, a small slice of silicon, allowing the world's thinnest iPhone to manage its screen without waking the rest of the chip.